Good morning, everyone. UI 2026 fresher. Welcome to my YouTube channel. Welcome to Genius Code YouTube channel. Well, how has been UI so far? Definitely. So today I'm going to be explaining a particular concept in physics 101 that we call what? Work, energy, and power. Just like this particular topic might seem simple, but it's complex somewhere. So let's get to the whiteboard. So today I'm trying to be explaining work, energy, and power. What do we understand by work? In anything that you want to understand by work, just that work is the product of what? Of our force and what? And displacement. W, just from your expression, W is equal to what? Force times displacement. It's not distance. Please take note. Because work done is a scalar quantity, which is gotten from the combination of two vector quantity, your force and your what? And your displacement. So after knowing that your force, just know that your work done is a what? Is a scalar quantity. Your force is a what? Is a vector quantity, and your what? And your displacement is a what? Is a vector quantity. By the time you have the cross product of both of them, then you are going to get a what? Then you are going to get a force, or you are going to get a work done. So how can we do about calculating our work done? I want you to know some important formulas. If you said W is equal to what? Force times distance plus what? Cos theta. This particular formula is explaining to you that how you can get the angle between the force and the what? And the displacement. Let's take for an example. This is a particular diagrammatic expression that is trying to explain what I'm trying to explain. If this is a particular displacement and a particular force is moving in this direction, the angle between this particular force and this displacement can be calculated using my W is equal to what? Force times distance cos what? Cos theta. Please, students always make the mistake. It's not sin theta, it's cos what? Cos theta. Now, let's explain how it is what? How it is vector. Yes, you understand that my force can be in components in high, J, and K components. Then the same thing as my displacement. It can be in what? It can be in components high, J, K. But UI always give what? They always still give displacement in form of points, where you have a point A and you have a what? And you have a point B. I will try to solve a particular example now. Maybe you will be able to understand from there. If they say calculate the work done, given that your force is equal to what? My force is equal to 7i plus what? Plus 5j plus what? Plus 6k. In a particular displacement of 2 points, let's take points, and the first point to do what? To be P, to be equal to what? 2, 1, 3. And the other point is what? And the other point is Q, which is what? Which is 1, 2. If you see this particular question is very so much easy to understand. It's very so much easy because I can easily represent this particular point. Each point is what? Is displacement. I can still represent it based on their what? Based on their components. Then I cannot say this one is my I, this one is my J, and this one is also my what? My K. Same thing as this one. This one is my I, this one is my J, and this one is my what? This one is my K. So for me to get a particular displacement that I'm going to use to multiply this particular force, I must subtract this one from this one. Am I communicating? So please listen carefully to me. So I'm going to subtract 2 minus what? Minus. So the first thing I'm going to do is that what? I'm going to subtract 2 minus 1 to give me what? To give me high, right? Or maybe I should just write 1 high. Then the next thing is that I'm going to 1 minus 1. 1 minus 1 is what? 1 minus 1 is what? Is equal to 0 what? 0k. Then I'm still going to subtract 3 minus 2. Right? So I'm not going to 3 minus 2 is equal to what? Is equal to what? 1 what? 1 z. When I communicate, oh sorry, this one should be J, then this one what? This one should be K. So I've already resolved my displacement into what? Into a particular vectorial representation that has what? That has a particular component. So I cannot say that my overall displacement is what? Is high plus what? Plus 0G plus what? Plus K. So now, how will I now get my what? My work done? Is by multiplying this one by what? By my force. That's how I'm going to get my work done. So to get my work done, then I will say that what? So to get my work done, then I will say that my work done is equal to what? My work done force times what? Times displacement. Then you don't forget that we have our displacement to be equals to I plus what plus 0j plus what plus k, right? In which we are not going to be multiplying all this variable with this particular. So we can get I, we can get the first one is what? 7 times what? 7 times 1, which is equals to what? Which is equals to 7. Remember, your I times I will have multiplied each other. That is the what? Vector component rule. I times I is equals to 1, j times j is equals to 1, and what? And k times k is equals to what? Is equals to 1. So same thing as this again. Then I'm going to multiply 5 times what? 5 times 0k. So at the end of 5 times 0, that one will be equals to what? Will be equals to 0. Am I communicating? The next one is what? 6 times what? 6 times 1k. This is 1. Please, the coefficient is what? Is 1. Then I'm still going to say 6 times what? Times 1 is equals to what? 6, right? So because all this particular matching component is equals to 1, so I cannot say I will have what? 7 plus what? Plus 0 plus what? Plus 6 as the value of my what? Then I cannot say I have 13 what? 13 joules as the value of my what? Of my work done. Am I communicating? So this is how we solve this particular question. When you have 2 points of what? Of a particular displacement, you make sure that you find a way to convert those displacements into a particular single vectorial representation. Then you try to multiply it by what? By the force that you were given. Another case. We might also be asked to calculate your particular vector. Imagine you were given your force to be equals to what? 4xi plus what? Plus 3y what? Plus 3yj. Plus 3yj. But they now say that what? They now say that the force is acting along my x direction from the origin to a particular final displacement. The force is acting in what? In which direction? X direction. Right? From the what? From the origin, anywhere you are origin, automatically is starting from 0, what? 0 to my what? To my final displacement, which is what? Which is 5 what? 5 meter. Now say calculate the work done. This is the typical examples in your slide. But how will you now be able to calculate this one? It's so very, very simple. Just calm down, relax, and follow me. If you want to try to solve this, they said in next direction, meaning that what? They are making emphasis on next direction. Or meaning that everything about y direction is equal to what? Is equal to 0. So I will now be able to say my force is equal to what? Is equal to 4xi plus what? Plus 0. After I've already done my force. You all know the reason why this one is possible, because we are not regarding anything about y axis. We are only talking about what? About x direction. Am I communicating? So after I've already sorted it out now, then what will I do? The next thing I'm going to do is that I'm going to integrate this one. This is my force. I'm going to bring my 4xi. I'm going to do the definite integral from the what? From the final to the what? To the initial, which is what? The definite integral of this one from what? From 5 to what? To 0, because they are talking about from the origin to the what? So the 5 meter. Am I communicating? And we all know in rules of integration that if you have what? If you have 4x, automatically this one is going to be 2x squared. You're going to add 1 to the initial component that is empty, and this one is going to be over 2. Right? So I'm not going to plug in the values of what exactly am I looking for. They already give me that the final one is what? Is 5. Let's calculate for 5 first. Then if I put what? If I put 4 over 2 into bracket 5 raised to power 2, then this one equals to 2 times what? 2 times 25. Then I'm going to get what? I'm going to get 50 joules. I've already done this one for the final. Now let's do for the initial again. But for the initial, they said what? They said is equals to 0 now. 0 from the origin. So automatically that one will be definitely equals to 0. But I have to subtract my what? My final from my initial. So I'm going to do what? I'm going to do 50 minus what? Minus 0. Then I'm going to get what? 50 joules. So that makes the work done in that particular system, the work done on that particular force to be equals to what? 50 joules. So please don't depend on this example. Try to solve the same example and try to what? Change values. So that is all about your work done, and what? I've already revised the formula on how to get the angle between what? Between your force and the what? And the displacement. Note, work done is a what? Is a scalar quantity gotten from the combination of the product of two vectors, which is what? Your force and my what? And the displacement. Now let's go back to what? Energy. What do we understand by energy? Energy is the capacity to do work. Yes, if you don't have energy, you will not be able to do anything. That was, if you notice the clock, A rounding clock, you need to add what? You need to put a particular energy, which is the form of your battery, that will act as a chemical energy so that it can be able to carry the work of the what? Of a mechanical energy. So that was the reason why we define energy as the capability or ability to do work. So note, students makes it wrong here. We have differences between what? Between my forms of energy and what? And types of energy. You can have several forms of energy, ranging from what? A lot of them, ranging from mechanical energy, thermal energy, chemical energy, heat energy, all the way for. But we only have two types of what? Two types of energy. Take note. We have two types of energy, which is my what? Kinetic energy, and my what? And my potential energy. Good. So what students do not understand is that kinetic energy and potential energy, they are only the two types of what? Energy that we have. Other energy are what? They are forms. That was the reason why the law of conservation states that what? Energy can neither be created nor destroyed, but it can be converted from a particular form to another. From chemical energy that is inside the battery being converted to the mechanical energy that the clock is using to do the work. Am I communicating? So let's move on. So what is kinetic energy? Kinetic energy is the energy that by virtue of motion. Because your kinetic energy is a function of velocity, and what energy, any energy that is responsible for you to be able to be changing position, that's what we call kinetic energy. And the formula for kinetic energy is equals to what? Kinetic energy is equals to half what? Half mv squared. Am I communicating? That is the mass and the what? And the square of the what? Of the final velocity. Am I communicating? The same thing as our what? Our potential energy. Our potential energy is an energy due to what? Due to a particular position. When I state somewhere now, one energy is holding me down, which is what? Which is my potential energy. It is in chemistry that we know that under potential energy, we all have some forces that are called what? The intermolecular forces and the intramolecular forces. But this is physics 101. We don't really need that. So am I communicating? So my potential energy is just what? It's just my what? My mg what? Mgh. That is potential what? Potential energy. That's mg. By the time you subject a particular string to a particular acceleration due to gravity, you consider the mass of the string, the height of the string, and what? Acceleration due to gravity that makes the string to still hold a thing. So that's what we call it. Mgh. But sometimes our work done can also be equated to our potential energy. Take note. Our work done can also be written as W is equal to mgh. Yes. When we are considering the work done that is happening at a particular static position. Our work done can also be referred to what? My work done can also be equal to half mv squared. Considering the work done of a particular body in motion. Please take note of that formula. It's not only every time that maybe you need work done, then they will not give you the value of your force. They will not be like, what? No, you might be given your mass, your acceleration due to gravity, and your what? And your height. It's just like this work done is work done due to what? Due to an acceleration due to gravity. And we explain for you now. Fine. If I said my work done is equals to what? My work done is equals to work done is equals to what? Is equals to force times what? Force times displacement. But we all know from our simple physics that my force is equals to what? Is equals to ma. But I told you something. We are considering gravity here. So acceleration due to gravity will be used in place of what? The normal acceleration or the linear acceleration. I'm going to get so instead of me saying that my force equals to ma, then I'll say my force is equals to what? Is equals to mg. Then coming to the displacement. Since we are talking about something that is coming from gravity, then we are talking, anytime we are considering this, we always consider the height of that particular object. Then now we have what? Times h. So automatically my work done will be equal to what? Mgh. Right? So that is just it. Then my work done can also be equal to my kinetic energy. That is it. So just know that my work done is equal to what? Half mv squared. So I've already explained the energy. I've already explained what exactly work done is. So now let's come back to the third thing, which is equal to what? The power. Yes, we do note that power is what? Power is the rate of doing work. We are definitely correct. Power is what? Power is the rate of doing that. Is power is equals to what? My power is equals to work done over what? Work done over what? Over time. Over time. But this particular work done can also be equal to what? My power is equal to what? Force times what? Force times displacement over what? Force times displacement over what? Over time. When my displacement over time is what is given what is my what is my instantaneous what this instantaneous velocity. So I can say my velocity is equal to what? Displacement over what? Displacement over time. Then I cannot say that my power is equal to what? Is equal to force times what? Force times velocity. Please take note of this formula. Your power can be calculated using work done over time or what? Of force times what? Force times velocity. Look at how I get the formulas. So in physics, they are not creating magic. Everything have been analyzed step by steps. So in replace, I can still write this particular formula since I know that what my work done can definitely be equals to what? Can definitely be equals to mgh or what? Or half what? Half mv squared. So automatically I can say my power is equals to what? My power equals to what? Half what? Half mv squared over what? Over time. Or better still, I said my power is equals to mgh over what? Over time. But note, your power is a what? Is a what? Is a scalar quantity gotten from the combination of your force and velocity. It's still like the same thing as work done. Work done is a scalar quantity gotten from the combination of force and displacement. My power is a what? Is a vector quantity gotten from the combination of what? My force and what? And my velocity. Am I communicated? So that's just it. Then we can also ask to be calculated the angle between the force and the velocity that makes up the power. Then I can say that my what? My power will now be equals to what? My power will now be equals to my power is just same thing as what done here. My power equals what? Force times what? Times velocity equals what? Cos theta. Maybe the theta is what? Is the angle between my force and what? And velocity. So that I can say that my power will be equals to 0 when my what? When my theta is equals to 90 degrees. You know, we all know that what? Cos 90 is equals to what? Is equals to 0. So automatically the 0 is going to affect all the formulas. Then I can say that my power is equals to what? Force times velocity times what? Times 0. Then my power will now be equals to 0. Please note, you will have a minimum power to be equals to 0 when your what? When your angle between the force and velocity is equals to what? Is equals to 90 degrees. Am I communicating? So that's just the explanation of what? Of your power, energy, and work. So simple as what? As ABC. But let me try to explain something to you as well. We have what we call the work energy theorem. The work energy theorem is trying to state that what? The work done is equals to the what? Change in kinetic energy of the two body what? Of the two body in motion. Whereby what? I said my what? My work done what? My work done theorem. My work done theorem will now be equal to state that what? My W is equals to what? Change in what? Change in kinetic energy of the two body motion. So I can say my W will now be equals to what? Half mu square minus what? Minus half what? Half mv what? Mv square. Where your u and v are the what? Are the initial and final velocity respectively. So thank you very much for watching this video. I think this particular video explains something on what? On work, power, and what? And energy. So now let's go back to questions. So you have an example 1 that says that what? Example 1. So this is a typical example. This is an hypothetical example. The example is not in your slide. So the example said that would calculate the given a body of what of mass 5 kg moving with a what with a velocity of 5 meters per second and what and a mass of what 0.05 kg moving with a velocity of what 2 meters per second. Calculate the work done. Since you have two masses, then you have what two velocity. The next thing that's supposed to come to you, this is work energy theorem or work energy relationship. Where I'm still going to say that my work done will now because what changing my kinetic energy. You calculate the first kinetic energy and the second kinetic energy, then you subtract from each other and my communicator. So thank you very much for watching this video. Please, when you watch this video, like, comment and subscribe. See you in my next video.